Hello, YouTube community. Once again, I'm back. I'm Erisa Wante to take you through discrete random variables. Yesterday, we discussed what a random variable is. We introduced it and we went ahead to look at the probability distribution. Okay, so this is what we are discussing. Distribution. So to talk about the probability distribution and understand it fully, we used an example yesterday, and I'm going to bring this back today so we can continue understanding what a probability distribution is. This example is what we discussed yesterday to better understand probability distributions. Okay, I have just picked it up to carry on with it so I can use it to explain the point of probability distribution. Now, we calculated yesterday and found out that the probability that we have no faulty fuse was equal to 0.1. Then for one faulty fuse, that was 0.6. And the 2, the probability was 0.3. Okay, now what is important here is the probability distribution. Okay, we let x, okay, be the number of faulty fuses. And we said the probability of x, we can write this as the probability of x is equal to 1, okay, is equal to 0, no faulty fuse. We can write this as 0.1. Probability of x equals to 1, we can write this as 0.6. And then the probability of x is equal to 2 is 0.3. So we went ahead to summarize this information in a table. Okay, let me show this table, what we came up with yesterday on the next page. This is the table showing us the probability. So we have summarized it. And if we want to plot probabilities against x's, you know, x, small x, or lowercase letter, is the value, the variable x. Okay, 0, 1, 2, 3, that's lowercase. And the capital is the name of the variable. So here, capital X is standing for the number of faulty fuses. So if we are to represent this on a vertical line graph, then we shall end up with, we did this yesterday, but I'm just repeating myself. Okay, so this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So this is 0.6. This is 0.3, and then 0.1. Okay, so x is equal to 0. We have a line which is vertical. Okay, let me change the color so I can use the blue. Okay, and the x is equal to 1, then x is equal to 2. So for 1, the value, the probability is 0.6, so you draw a vertical line. Okay, and then for 2, it is 0.3. Okay, so this is a plot of probability P of capital X is equal to small x against x's. Okay, every time you are told to plot the p.d.f of a discrete random variable, it is gonna be vertical line graph. Probabilities are plotted on the vertical axis, and the values, or the x values, are plotted on the horizontal axis. So that was done yesterday. Okay, we did that yesterday, but you know, today we want to emphasize the point of probability distribution. Okay, so before we go to probability distribution, there is something we must know that qualifies a variable to be random. What makes a variable random is the sum of probabilities. If the sum of probabilities is 1, the variable is said to be random. Let me write this statement. If the sum is 1, okay, then what happens is the variable is said to be random. So what makes a variable random is the sum of probabilities. So if you check here, the probability of x is equal to 0 plus the probability of x is equal to 1 plus the probability of x is equal to 2 will be 0.1 plus 0.6 plus 0.3, and this gives you 1. So x is a random variable. Okay, what makes a variable random is the sum of probabilities. If the sum of probabilities is equal to 1, then that variable is random. And what makes it a discrete random variable is the value the variable takes. Okay, here the value, okay, the variable takes exact values 0, 1, 2, 3. You cannot find that the probability of x is equal to p of x is equal to 2.5. No, that will never happen because this has to be exact values. So if the values are exact, then we say it is a discrete random variable. Okay, we shall always use the Greek letter, okay, epsilon, to mean summation. So we shall always have this to mean the summation, okay, of the probabilities for all x values. Or you can write the summation. This is rarely used, but we can also use it to write the summation of probabilities equal to 1. This is the most common you're going to find in most cases. So that is it. These are some of the facts we have to know about the discrete random variables. Okay, what makes a variable random is the sum of probabilities. If it is 1, then it is a random variable. What qualifies a random variable to be discrete are the values the variable takes. If they are exact values, then that variable is random. For example, if you are throwing a die and your interest is to know the number of falls you get, okay, and then you do throw the die maybe 5 times, then the highest number of falls you can get is 5. But you may end up not getting any 4 out of the 5 throws, or you can get 1 4 or 2 or 3, but the highest number of 4s you're gonna get out of 5 throws is 5. Okay, so you will find that the number of 4s will be an exact value. It is either 0 when you don't get anything, or it is 1 when you get 1 4, 2, or maximum 5. Okay, so that kind of variable which takes exact values is what we call a discrete variable. And if the sum of probability is equal to 1, then it qualifies to be called a discrete random variable. So let me hope I've made the point so clear to you. So what is the p.d.f? p.d.f is the function that is responsible for allocating probabilities. Okay, p of x is equal to small x is known as the probability density function. In bracket, we can abbreviate this as p.d.f of x. Okay, the probability density function can either list probabilities individually or summarize them into a formula. Okay, so simply what we are saying is that the function that is responsible for allocating probabilities, okay, which function? This is the function. It will allocate different probabilities to different x values, is known as the probability density function. So you'll find this abbreviation frequently used, the p.d.f of x. The probability density function can either list individual probabilities or summarize them into a formula. So, like the previous example, you know, the p.d.f was listing individual probabilities for x is equal to 0, for x is equal to 1, for x is equal to, but we can also have the p.d.f, you know, giving us the probabilities as a formula. Let's look at this in the next example. The example says the p.d.f of a discrete normal variable y is given by this formula, probability of y is equal to y is cy squared, for the stated y values 0, 1, 2, up to 4. Okay, given that c is a constant, find the value of c. Okay, so this is a simple problem that you can solve with just the knowledge you have gained in discrete random variables. Okay, what have we learned? There are two key points we have stated. The sum of probabilities equals to 1 makes a variable random. Okay, and if the values the variable takes are exact values, then it becomes a discrete random variable. So let's have the solution. Remember, a discrete random variable will be represented by a capital letter. Okay, probability of y is equal to small y. You know, the small y's are the values the variable takes. Capital Y takes small y's in terms of values. Okay, so let's look at the formula. The formula is the probability of y equals to small y is given as c y squared. For which values of y? 0. Okay, see, remember c is a constant, so when 0 squared is 0, so this is 0. Okay, when y is equal to 1, this will be c. Okay, when y is equal to 2, this will be 4c, because 2 squared is 4. Y is equal to 3, you'll have 9c for 3. And then lastly, y is equal to 4. Okay, this will be 16c. Okay, that's the probability density function, or the p.d.f is py is equal to, so this is a table summarizing probabilities. So what do we know? The summation of probabilities must give us 1 for all the y values. If you want, you can summarize for all y values. Okay, this statement is the same as writing for all, okay, y. So if you want mathematically, you can represent it with that. Okay, it is an inverted A for all. So with that statement, we can get the value of C, you know, sum the probabilities. What does it mean? That the probability of x is equal to, of y is equal to 0 plus the probability of y is equal to 1 plus the probability of y is equal to 2, whatever must be equal to 1. So since we have the probabilities in the table, let's just get them and sum up. Okay, so we have 0 plus c plus 4c plus 9c plus 16c will give us 1. Okay, so what's that? 14 and the 16, what do you get? 30c is equal to 1, and the c will be 1 out of 30. We are done. That's the value of c, and the question is talking about c, so we have the answer. C is equal to 1 out of 30. Okay, so next, Let me see. Let me put this example for you. We have this example. They have summarized a table for you, and they are asking for the value of A. Probability of X is greater or equal to 4. Probability of X is less or equal to 1. And the probability of 2 less or equal to X less or equal to 4. So, how do we find the value of A? Solution. Okay, we have probability of the value of A. Sorry about this. I'm really sorry about that. Okay, find the value of A. We know that the summation, okay, summation of the probabilities must give us one for random variable. So what are we summing for all values of X? Okay, so what are the probabilities? We have 1 over 10 plus 3 out of 10 plus A plus 1 out of 5 plus 1 out of 20. Okay, this gives us 1. So you sum. The LCM is 20. Okay, 20 by 10 is a 2 plus a 6 plus 20A plus a 4 plus a 1 all over 20 gives us 1. Okay, so what is A? A is equal to, okay, this is going to be 20, okay, minus 2 plus 6 is 8 plus 9 is 13, okay, out of 20. Okay, so what is A? A gives us 7 all over 20. That's the value of A. Okay, so as simple as that, you have the value of A. Now the next part, they want to get the probability of X greater or equal to 4. X values that are greater or equal to 4. What do we get? So the probability of X greater or equal to 4 will be equal to, let's see the values we are going to consider. We want X values that are greater or equal to 4. So we have probability of X is equal to 4 and the probability of X is equal to 5. Okay, so what do we get? Let's sum. This 1 over 5 plus 1 out of 20 is 5 over 20, which is 1 over 4. Okay, so the probability that X is more than or equal to 4 is 1 out of 20. So which other part? There is part C. C talks about probability of X less than 1. Okay, probability of X less than 1. Do we have any X value in the table that's less than 1? No, so that is a 0. Okay, then D is the probability of 2 is less or equal to X less 4. Okay, so we want X values that are greater or equal to 2, but must be less than 4. And when I check here, these are two values. The probability of X is equal to 2 and the probability of X is equal to 3, because 4 is not part of this. We are looking for values that are less than 4. So we don't take a 4, but 2 and 3 are taken. So what is the probability of X is equal to 2, that is 3 out of 10, plus A, the probability of X is equal to 3, which is 7 out of 20. Okay, so what do you end up with? Okay, this is 6 and 7 is 13 out of 20. That's the probability that 2 is less or equal to X less or equal to 4. So we have solved the problem, ladies and gentlemen. What facts are we emphasizing in solving these problems? Okay, the first was summation of probability is equal to 1. And then the other part is that this variable takes exact values. So they are countable values. If they say less than 4, look what values which are less than 4. That is 3, 2, 1. But if you're going to look for values that are more than or equal to 2, then you don't go beyond the 2. You don't go below 2. Okay, so that is it. Here is our second last example. They are giving us a discrete unknown variable. This time it is R, and it has a PDF. What's the PDF? The probability of R is equal to lowercase r is C into 3 minus R, okay? For R is equal to, and C is a constant, so they want us to find the value of C. What is it here? What do we do? Okay, let's just summarize this into a small table. So solution, okay, I have R and the probability. Let me change this and use, I have R, then probability of capital R is equal to, okay, so what values will I consider? 0, 1, 2, and then 3. These are values. Okay, so what do we have for 0, for 1, for 2, and for 3? When the formula, remember the formula is probability of capital R is equal to R is C into 3 minus R, where R is 0, 1, 2, or 3. So when it is 0, 3 minus 0 is 3, so this is 3C. Okay, when it is 1, it is 2C. Okay, this is a C, and here it will be 0. So how do we find C? We know the summation of the probabilities of R is equal to R for all values of R. Okay, this gives us 1. So you sum. Okay, what do you get? 3C plus 2C plus C plus 0. You end up with the, that's 5. 6C is equal to 1, and C is 1 out of 6. Okay, so you have C as 1 out of 6. Just interesting. So from there, I want you to draw a vertical line graph to illustrate the distribution. Let's draw it. So let us draw a vertical line graph to illustrate this distribution. Okay, we have the vertical and the horizontal axes. So on the vertical axis, we're gonna put the probabilities. Probability of R is equal to small r. And remember, they go up to maximum 1 out of 6, 2 out of 6. So the highest is 3 out of 6. So this is 1 over 6. This is 2 out of 6. And this is 3 out of 6. So 3 over 6, 2 over 6, 1 out of 6. And then the values we have 0, okay, 1, then 2, and 3. Okay, so what are the probabilities? Let me change the color so you can see what I'm trying to draw. For 0, this is gonna be, the value is gonna be 3 out of 6. Then 2 over 6 for 1. Okay, 2 over 6. And then for 2, it is 1 out of 6. Then 3 is 0. Okay, so 3 is just here. This is 0, 1, 2, and 3. So these are R values. Oh, no, lowercase, not uppercase. It must be lowercase. So this is R. Okay, so that's what we end up with when we are told to draw a vertical line graph. That's the vertical line graph for the distribution. We have it, ladies and gentlemen. So what next after the vertical line graph? They want us to go ahead and find, okay? They want you to find the probability. That's now part C. This was part B. Okay, the probability of 1 is less or equal to R is less 3. So which values are we considering here? 1 is less or equal to R is less or equal to 3. So we have the probability of R is equal to 1 plus the probability of R equals to 2. Okay, so what are the probabilities? P of 1 less or equal to R less 3 will be equal to, okay, for R is equal to 1, we have 2 over 6. Okay, and R is equal to 2, because the one less, okay. For R is equal to 2, we have 1 out of 6. So 3 out of 6, the same thing as a half. And we have solved the problem, okay. So ladies and gentlemen, this is for sure a walkover for this first part. Not all that so difficult, so anybody can solve these problems. But we shall see as we move on. We shall also have a special discrete, which we call the binomial distribution. We shall see about that when we get there, okay. Now, next, which is going to be the last example, okay. I think this is easy, but let me do it first since I promised you. All right. Lastly, we solve this problem. It says x can take values 5, 6, 7, 8, and 9. The vertical line graph to illustrate the distribution of x is incomplete. Given that, so they're giving us some information, and this information here is going to help us to find the probability, okay? Given that probability of x is equal to 8 is twice the probability of x is equal to 9. So they are saying we complete the line graph and also describe the distribution, okay? So what do we, now to be able to solve the problem easily, let probability of x is equal to 9 be some value, maybe k, okay? So when that the summation of all probabilities for capital X is equal to small x must be equal to 1 if we take all of values of x given, okay? So what do we do here? This is what we do. We say, look at the line graph. 5 has probability of 0.1. 6 has probability of 0.2. 7 has probability of 0.4, okay? And we know that 8 and 9 must have the remaining probability to make 1. But I'm calling the probability of 8 or of 9 equals to k. So the 8, it will be 2k plus k equals to 1. Okay, so 0.1 plus 0.2 plus 0, that's 0.7. 0.7 plus 3k gives us 1. Okay, k is 0.3 out of 3. Okay, if you want, you can write this as 1 out of 10. So the value of k is 1 out of 10, which is the same thing as 0.1. Okay, so if you are to complete the vertical line graph, probability of x equals to 8 will be twice 0.1, which is 0.2. Then the probability of x is equal to 9 is 0.1. So you can complete this and say for 8 it is 0.2, and then for 9 it is 0.1. So 9 has a probability. Let me try to level it so it looks good. That's 8 and that's 9. Okay, now when you check that distribution, okay, because they're telling us to describe the distribution, if you have such a distribution where the values balance, their probabilities balance on either side of a value with the highest probability, then that becomes a symmetrical distribution. So we can write and say that x is a symmetrical distribution. Okay, that's the kind of distribution we are having. It is symmetric about a particular x value, which is equal to 7. So you have the probability of x is equal to 6, is the same as the probability of x is equal to 8. And the probability of x is equal to 5 is the same as the probability of x is equal to 9. Okay, it is only the probability of x is equal to 7, which is unique and is the highest. So in this kind of distribution, the mode is going to be 7, because 7 is the x value with the highest probability. Okay, So this is the mode. X is a uniform distribution. That is it, ladies and gentlemen. So, ladies and gentlemen, thanks for watching. Okay, and remember to drop a comment. You can also contact me through my email if you have, or if you need some kind of private arrangement, I need some help in somewhere in mathematics, because this is general, but different students have different problems. So thanks so much for watching. I wish you the best.